All right, so we're going to practice graphing some reciprocal trig functions. And what I actually recommend is if you're going to graph the reciprocal, then graph your reciprocal, right? So you're going to graph 3 sine x, and then that's going to help me actually graph 3 cosecant of x, right? So let's start with 3 sine of x. So we're going to start at 0. We're going to go up, since the amplitude is 3, we're going to go up to 3, back to 0, down to -3, and then back to 0. So I'm going to go ahead and put my sine graph here is going to look, let's get that a little better. My sine graph is going to go here, back down, and then back around here. Okay, now, if I want to graph 3 cosecant of x, the best way for me to think about this, or the way I like to think about it, is that every time sine of x is 0, cosecant is going to be a vertical asymptote. So I'm going to go ahead and put a vertical asymptote here. I'm going to have another one here, another VA here at pi, and the next time when it's 2 pi, I'm going to have a VA as well, okay? So I'm going to put these vertical asymptotes here, and that's going to help me kind of set up the other graph. Now, keep in mind that when y equals 3 sine of x is equal to, well, what would normally be 1/2, but in this case would be about 1.5. Well, then this is going to be here. You're going to have 3 times that, right? It's going to be alternating, is what the point I'm trying to make here. So if we look to see, like as sine of x gets close to 0, cosecant of x is going to go up to infinity. And so that's why you have these arrows going up here, and they're going to go up to infinity as sine gets really close to 0, right, in both directions here. And now the same thing is going to happen, except for that it's negative. And remember that in this case, since we have an amplitude of 3, when sine is 3, then cosecant will also be 3. And when sine is -3, cosecant will also be -3. And obviously this would continue on after this, but you have one full period of the function graphed after this. Okay, let's go on to the next one over at the right. Notice we have y equals -2 secant of x. So my reciprocal is going to be -2 cosine of x, right? So let's start by graphing that first. Now, normally we would start up at the top and go down for cosine, right? But because this is negative, we're going to start at the bottom, which in this case is going to be -2, and then go up to 2. Right, so let's graph this one. We're going to have it going up to pi at 2, back down to 0, and then through -2 at 2 pi. Okay, now, same thing as before. Every time cosine hits 0, secant is going to have a vertical asymptote. So let's go ahead and look at that. So here we got cosine is hitting 0, so we got a VA right here. And then we have another one at 3 pi over 2. And the next one would actually be at 5 pi over 2, but we don't have to put that full one there. The important thing here is that we have 2 full cycles of, one period of the graph, which is actually just 1 cycle. So, okay, so now remember, same thing as we have here. As cosine gets really close to 0, this case is coming from a negative, then secant is going to go towards -infinity. So it makes this alternating arc here. And same thing as that gets close to 0. And in this case, they intersect at -2 here, at 2, and at -2 here. All right, so now we've drawn 2 reciprocal graphs here. Let's go down here. We're going to go down now, and we're going to look at graphing y equals cotangent of x. Okay, so how am I going to do this one? Well, remember that cotangent of x is just cosine over sine. Right? So the way I look at this is, well, every time cosine is 0, cotangent is 0. So I'm going to go over here and I look at my cosine graph, and I know that at pi over 2, also at -pi over 2, 3 pi over 2, and 5 pi over 2, cotangent is going to be equal to 0. Okay, now whenever sine is 0, we're going to have a VA. So we're going to have a vertical asymptote here at 0. And then we're going to have another one here at pi. And so my attempts at dotted lines, we're going to have another one here at 2 pi. Right, and then we're gonna, and well, we're not gonna extend the graph any farther, but obviously it would go on infinitely in both directions. Okay, so then final thing, right? We got to think about what's happening here. Is my graph going up or is it going down? Well, if you think about it, right, as we come from right after 0, right, cosine is 1 and sine is really small. So that means it's coming from, you have a really large number over a really small number. It's going to come from positive infinity. It's going to go through here, and then it's going to go down to negative infinity. And then the process repeats here. And let's draw it one more time here, and then it repeats again here. And now we've graphed the graph of cotangent of x. You could do this extra one if you want, but really, as long as you have 2 of these graphed, you have 1 full period of the cotangent function.